Hello and welcome to a Maths with Harry lesson. In this video we're going to have a look at reciprocal graphs. Now first thing we're going to do is we're going to have a look at what is a reciprocal. You might already know this, but let's have a look at what a reciprocal is with three numerical examples. I've got three examples here. We're starting with 2, we've got 100 and we've got pi, okay? Each one of those is a number. 2 and 100 are integers. Pi is a irrational number. To work out the reciprocal of a number, we don't really need to actually work it out. All we have to do is just write 1 over that number. So the reciprocal of 2 is just 1 over 2. In other words, a half, okay? The reciprocal of 100 is just 1 over 100, okay? And the reciprocal of pi, well, pi is still a number, we're just going to write it 1 over pi, okay? So to work out the reciprocal, we just take the number and we write it 1 over that number, okay? In other words, we're kind of flipping the fraction. We can think of 2 as being the same as 2 over 1. We just don't need that invisible 1 there. So then all we're doing is just flipping the fraction. The 1's going to go on top, the 2's going to go on the bottom to give us 1 over 2. And the same for 100 and the same for pi. Okay, it also works the other way. The reciprocal of a half, we can see we can follow this arrow. Flipping the fraction gives us 2 over 1, or writing 1 over a half gives us 2 over 1, which is then just 2, okay? Again, the reciprocal of 1 over 100 is just 100, etc. Okay, so those are three numerical examples. Now, what happens if we want to look at functions? So I have three functions here. We've got our general straight line, y is equal to x. It's the straight line through the origin. We've got y is equal to x squared, which is our quadratic, and it has a turning point at the origin. And then here is just a negative straight line, okay? Minus x over 2. What are the reciprocal of those? Well, we're going to do the exact same thing, and we're just going to write 1 over the function. So in the first example, y is equal to x squared. The reciprocal is y is equal to 1 over x, okay? Different function, it's the reciprocal function. We write 1 over the function that we've got. Here the function is x, so we're going to write 1 over x, okay? The second example is x squared, or y is equal to x squared. The reciprocal function of that will be y is equal to 1 over the function here, which is x squared, okay? And then if we look at the final example, just like we did here, we had 2 over 1 and the reciprocal was 1 over 2. We're just going to flip the fraction. So here, all we're going to do is we're going to keep the sign, it's still going to be negative, but then we're just going to flip the fraction. And what we're actually doing is writing 1 over x divided by 2 with a negative out the front. And then that just gives us the answer, and that's the same as just flipping the fraction. So minus 2 over x. Here the 2 was on the bottom, so it's going to be on the top in the reciprocal, and the x was on the top in the function, so it's going to be on the bottom in the reciprocal, okay? So that's how we basically work out the reciprocal. We take our function and write 1 over the function, okay? So how can we sketch these reciprocal graphs? Well, we can do that by considering something quite important. You might have heard of asymptotes, and that's what we're going to use to sketch our reciprocal graphs. So we sketch reciprocal graphs by considering their asymptotes. But what is an asymptote? Well, an asymptote is a line which a graph something but never something. Let's fill in those somethings. An asymptote is a line which a graph approaches but never touches or never crosses, okay? So it's approaches here, the graph approaches the line but it never touches or crosses, and touches kind of considers the space that crosses, because if it doesn't touch then it's not going to cross. Okay, so if we, for example, had an asymptote, let's say it was a straight line and it was like that, and let's say we had a graph that came up like that, I don't know, let's say that was an asymptote of the graph, it's going to get closer and closer and closer and closer, but never touch. And if we zoom in, we were just going to get closer and closer and closer and closer and closer, but never touch. If this is the positive the positive direction, this graph we would say is tending to positive infinity. It's just going to carry on and never touch this line. If you got maybe a graphing package, you can kind of always zoom in and see that the line is getting closer and closer, but it's never going to touch no matter how far you carry on. So that's what an asymptote is, okay? And asymptotes come from values of maybe x that kind of explodes the function. If the function doesn't work at that value of x, then that value of x is an asymptote. Okay, and similarly for y as well. If it doesn't make sense for y to be a certain value in that function, then y is also an asymptote. Okay, so let's consider the function y is equal to 1 over x. Okay, it's the reciprocal of y is equal to x. We want to think, what value can x never be equal to? And that way we'll be able to work out the asymptotes, okay? And if you didn't have 1 over x, let's say you had maybe 1 over x squared, or you had a different function, it's the same process to work out asymptotes. We're going to first of all consider the value of x that just does not make sense. Whenever we've got x on the denominator of a fraction, we always need to consider when x is 0. When x is 0, what we're basically doing in this case is, well, x is 0, so we've got 1 over x, which is 1 over 0. If x is 0, we are dividing by 0. And hopefully you know that it doesn't make sense for us to divide by 0. So x can never be equal to 0. So we'll write that here, okay? X can never be equal to 0. So what that means is that x is an asymptote, okay? Does not make sense for x to be 0, so the graph y is equal to 1 over x can never cross the line y is equal to 0. In other words, it cannot cross the y-axis, okay? But let's consider, what about y is equal to 0? So it's always good to consider, well, we've got x on the bottom here, so it can't be 0. But what happens when y is 0? Well, let's do a little bit of maths here. We've got the function y is equal to 1 over x. So if y is 0, that means then, we'll write a little arrow here, 0 is equal to 1 over x, okay? And then we can cross multiply, in other words, just multiply both sides by x to give me 0 times x is equal to 1. 0 times anything is just 0, so that tells me that 0 is equal to 1. We know that's not true, so what that means is y is equal to 0 does not make sense for this function, because we end up with 0 is equal to 1, okay? So in other words, this function, 1 over x, can never be equal to 0, because when we put y is equal to 0, in other words, the function equals to 0, we get this weird statement at the end. So let's put a sad face there, that clearly does not work. So what that means then is y is also an asymptote. Now y is equal to 0 is an asymptote, so that means that the x-axis is an asymptote, because anywhere on the x-axis is y is equal to 0, okay? So let's consider how we can sketch that function. Now here, I've got the function y is equal to k over x, where k is a real constant. K is a real number, so it could be 1, it could be 2, it could be 3, it could also be negative. We've got the two versions here. We've got when k is greater than 0 and when k is less than 0. We've not got equal to 0, because then that just means, well, y is 0. Okay, that's just the x-axis. But I'm going to sketch when y is equal to k over x. If we have a larger value of k, our graph just looks a little bit bigger. It's further away from our asymptotes. Now I've got a reminder at the bottom here to sketch our asymptotes first. The two asymptotes were y is equal to 0 and x is equal to 0. So it's the two axes. X is 0 and y is 0. Okay? So let's put those on. We'll do them in a thick grey. Let's just make that a little bit thicker. So x is equal to 0 is the y-axis. Oops, let's make sure it's dashed, because that's how we usually draw asymptotes. So there's our first asymptote. And then y is equal to 0 is along the x-axis. So there's our second, okay? And then the shape, or the general shape for any 1 divided by x or 2 divided by x, for any k divided by x, looks like this, okay? We are either positive or negative, so we're going to have something in this part of the axis here, or something in this part of the axis here, and it's going to look something like this. I'm going to draw it like that, first of all, to get a nice shape, and then I'll just make sure that it looks right. It looks something, and I might make that a little bit better there. It looks something like that. Now, it does not have to be perfect. Your graph can look a little bit off as long as it's got the right shape and the asymptotes are on there. But the positive k over x graph looks something like that. Okay, and it's always useful really to write on the asymptote. So this is the asymptote. In fact, we'll write it in grey. Y is equal to 0, and that's the asymptote. X is equal to 0. Okay, so that's for when k is greater than 0. Now, just to consider a few values of k, let's say if that graph, the black graph there, was y is equal to 1 over x. Remember, k is greater than 0 here, so k is positive. And let's say in blue we did y is equal to 2 over x. I'll just move that down here. So let's say those were, in fact, we'll put it up there. Let's say those were the two graphs, okay? 1 over x is the black graph. 2 over x is slightly larger because we've got a 2 on the top. So it's just going to look a little bit bigger. And let's say we get the perfect shape actually. Let's duplicate that graph there. It's just going to look something like that. Okay, it's going to have the same shape, but just going to be further away from the asymptotes because we've got a bigger number on the top. Okay, if it was small, if we had a half, it would be a little bit smaller, but we've got a 2 here, so it's a little bit bigger than the 1 over x graph. Okay, now let's have a look when k is less than 0. If you remember the positive graph, the negative graph is just a reflection in the y-axis, because if we've got k to be negative, then we've got something like minus 1 over x, or minus 2 over x. And in fact, what I will do is I'll do that in a different colour. I'll do that in green, so that we can sketch 2 different graphs in a minute. Let's make that negative clearer. Okay, so minus 1 over x, it just looks like a reflection in the y-axis. So what we have is we have something that looks like, something that looks like this. And let me make sure that's in the right place. We have something there, and we also have something, something like this. And of course you wouldn't have this special iPad to draw your graphs. You just want to make it as curved and as neat as possible. We also need to put the asymptotes on there, so let's make the asymptotes a bit thicker so we can see them. And we've got 1 on the y-axis, that's when x is 0, and 1 on the x-axis, that's when y is 0. Okay, so that is what looks like, is the general shape of y is equal to minus k over x. That's what all the graphs look like, okay? And again, if we had a smaller number, so if we had y is equal to minus 2 over x, it would look slightly different, okay? It would be stretched a little bit because we've kind of got a bigger number, even though it's smaller, we've just got a negative. So it would look something like this if we did it in green, and I won't duplicate this time, I'll just do it quicker like that. Okay, it's a little stretched, even though the number is smaller, we have a negative out the front. If you ignore that, we've got a bigger number on the top, so it's going to stretch the graph a little bit more. Okay, yeah, let's say that was minus 2. It could also be minus 3 because we've got no scaling on the graph, we don't know. We just know it's a bigger number. Okay, so that's how the graphs change considering on the value of k that we've got on the top. And k is just a real number. But those are the general shape, okay? Now, if you weren't comparing 2 graphs, you don't know the scaling on your axes. So this actually could be 1 over x if you're not comparing it with another graph, if that makes sense, okay? But as long as you've got your asymptotes on there and you've got the correct shape of the graph, you're good to go. Let's have a look at the graph of k over x squared, okay? And then we've had a look at the 2 basic reciprocal graphs. So again, we've got two opportunities for k really. We've got k to be greater than 0 or k to be less than 0. If it is greater than 0, k is positive. And we know that x squared is always positive because x times x, if x is negative, we're going to get a positive. So x squared is always positive. So k is positive and x squared is positive. So that means k over x squared is positive. So when k is greater than 0, y is always positive. So we're not going to have anything in this part of the graph because this is where y is negative. Okay, so everything that's going to happen for this, the graph of 1 or k over x squared is going to happen up here. Okay. And if we've got k to be less than 0, we have the positive to be all up here. So when we've got k to be negative, for similar reasons, it's all going to be down here, okay? And the general shape of k over x squared looks like this. Again, we're going to have the same asymptotes. I'll draw those on. For the similar reasons that we had at the start of this video, x cannot be 0 and y can also not be 0. And then we'll also do them here as well while I've got the correct pen. Those are our asymptotes there. Okay, so that's x is 0 and that's y is 0. So the general shape of the graph looks like this. It's all going to happen up here because y is positive, and we've got two asymptotes to work with. So we're going to have something that looks like, not a straight line, something that looks like that. Okay, and also on this side as well. I don't know why it keeps going into a straight line. Let's try that again. That's better. Something that looks like that. Okay, that's the graph of y is equal to k over x squared. Okay, we can see we're approaching the asymptote here. We're going to carry on and carry on, but we're never going to touch it. And similarly down here, we're going to carry on but never touch the x-axis, and same for those points of the graph there. If k is negative, so if we have minus k over x squared, we're going to have something that looks like this, okay? All we're going to have, and I might actually be able to duplicate this so it looks the same. Let's see if we can do that. Oops. Let's see if that will work. If we duplicate this, and then let's see if we can spin that around. Perfect, we can do. It's going to look something like that. Okay, and just checking that's correct. That's it, that is correct. So we have negative k here, so instead of it all happening up here in the positive part of the y-axis, it's going to happen down here in the negative part of the y-axis. And the graph's going to continue all the way down here, but never touch the negative part of the x-axis. And all the way up here, it's going to carry on down there and up there as well, continuing to all the way, never touching the positive x-axis and carrying all the way to kind of positive infinity, if you like. Okay, so those are the general shapes. And again, I could draw different values of k on there. If we had, let's say, this to be k is equal to 1 over x squared, and in red, if we had y is equal to, y is equal to 1 over x squared, y is equal to 2 over x squared, or it doesn't even have to be 2, it could be 3 as well. We'd have something that kind of looks like that. Okay, and let's say the black one here is y is equal to minus 1 over x squared. We could have in orange y is equal to minus 10 over x squared, would maybe look something like that. Okay, so as long as you get the scaling correct if you're comparing graphs, then everything's good to go. Okay, let's have a look at the first example. On the same axes, we want to sketch y is equal to 4 over x and y is equal to minus 12 over x. So we're going to have the general shape of both graphs as long as you get the scaling correct, because we want to do them on the same axes here, so make sure they look right together. So pause and have a go if you want to, then press play and we'll work through the answer. Okay, if you've had a go, then let's see whether you've had the correct go. So y is equal to 4 over x. It's a positive number on the top. We've got a positive k value. So it's going to look like this general shape here. Okay, So we're going to have, first of all, asymptotes, and I have actually drawn them on, but let's make them, oops, not duplicate, let's, not that, oops. Let's make these a little bit thicker so you can see them. We'll pop the axis back on there. There's one of the asymptotes, and then, oops, not that. Let's make that asymptote a bit bigger. So, there we go. We can see we've got two asymptotes there. And all we want to do is draw the general shape, but because we've got a 4 on the top and not a 1, we want to stretch the graph a little bit. Okay, so it's going to look something like this. But because it is a 4, we'll have it looking a little bit further away from the asymptotes. And again, there, we'll have something like that. And I'll draw on here that y is equal to 4 over x. And it's quite easy to sketch these reciprocal graphs as long as you know the general shape. Here was the general shape. We started off up here and we finished off down there, not crossing these asymptotes. We've put the asymptotes on and we've got the general shape, okay? And I'll write these asymptotes on. X is equal to 0 and y is equal to 0. Okay, then we want to sketch minus 12 over x. Okay, so it's negative, so it's just going to look like a reflection in the y-axis. Okay, so all we're going to have here is something like this. If we look at the general shape, it's going to come like this and like that, again with the same axes, okay? And because we've got a 12 on the top, it's just going to look even further away from our asymptotes than the 4 over x does. And it's negative, so we're going to have it starting like this. Oops, not a straight line. Why does it keep going in a straight line? That's better. It's going to look like that, quite a bit further away from our asymptotes. And then over here, we're also going to have this part of the graph like that, okay? And we can see this is, I'll do it in different colours actually. I'll do this one in green. Let's change the colour of that. Okay, so we can kind of see they have a similar shape. They're in different places because one's positive, one's negative, but they just look a little bit further away from the asymptotes because of how they're sketched, basically, because of their values on the top. Okay, let's have a look at the second example. Here we're having a look at separate diagrams. We want to sketch 2 over x squared and 5 over x squared. So pause and have a go, and then we'll work through the answer. Okay, let's sketch them on different graphs. We'll do 2 over x squared over here. It's going to have the same shape as this graph here because k is positive, k is 2 here, so it's positive, and it's going to look something like this. First of all, let's just quickly draw on our asymptotes. We cannot have y being equal to 0, and we can definitely not have x being equal to 0. And similarly here as well, while I've got the pen on, those are the asymptotes for 5 over x squared. And 2 over x squared is going to look like this. There and there. Looking quite symmetrical. Not the best when you're just doing a quick sketch, but as long as the shape is there. And then 5 over x squared, well, it's greater than 2 over x squared, so it's just going to be a little bit more, oops, a little bit more like this. We can see it looks a little bit further away than the other graph, okay? Maybe it should look a little bit more like that. We'll try and get it a little bit better, but you will have a free hand, so it'll be better for you, okay? So that's y is equal to 2 over x squared, and that's y is equal to 5 over x squared.